This is Algebra 1 exam review for Chapter 2. All right, and we are starting with the distributive property and removing parentheses. So we talked about what happens when there is a term, whether that's a number, a variable, or combination of both, attached to either side of parentheses with multiple terms inside. To simplify that, we are distributing. So you take the number that's attached and you multiply it times each term that's on the inside, and then you further simplify after that if you can combine like terms, but most of the time that is not possible. Okay, so we're going to do 5 times m, and that's 5m. And now before you just bring down the plus, I like to consider, is this going to be a positive or negative number, and then put the plus or the minus based on that. This is 5 times positive 4, so it's going to be a positive 20, so I write plus since it's positive 20, and if it was negative, I would express that as a minus. All right, here the number is on the left side, and it's actually a full term, negative 7a. All of that is going to get multiplied times each one of these. When you multiply different letters or variables, they just get attached. If you're multiplying the same variable times itself, anything times itself can be expressed with an exponent, and so you add up all of your a's and all of the exponents that go along with that. If they have something that's different than a 1, and you add them together and combine. You do multiply the coefficients. This a and this b both have a 1 coefficient, this one being a negative 1. And so this negative 7 is going to kind of just carry through besides the negative part. So first part right here, negative 7a times a is negative 7. That's not going to change. A times a, these are really like a to the first. Anything times itself can be expressed squared. So a times a is a squared. And now this is a negative times a negative. So this is going to be a positive. I'm going to write plus. The 7 stays because it's really 7 times 1. And a times b just becomes ab. You cannot do anything with those. Don't write ab squared or anything like that. That's only when it's the same variable times itself. All right, next one. Distributing here. This is just a 6, so all of these variables will just stay. All we're doing is dealing with the coefficients of each term. So we have 3 terms, as we studied in Chapter 1. We're going to multiply them all by 6. So 6 times 3 is 18. The v stays. 6 times negative 8 is negative, so I write minus 48. The w stays. 6 times 9, positive, so I write plus 70. That's not 72. Answer key is incorrect. So if you look at this answer key, you see 6 times 9 is 72. Obviously, that's 9 times 8. So that's a mistake. Let's fix that here. All right, so 9 times 6 is 54, so it's 54z. All right, and now going from the right side, we have a 10b. So the 10 gets multiplied by each coefficient, and then the b is going to get multiplied with another b, which is squared, and times a c, which is bc. So let's one step at a time. 10 times 2 is 20. B times b is b squared. 10 times a positive 1 coefficient here is still positive 10. And then the b and the c combined, we normally put those in alphabetical order, so we would write b, c. Okay, section number 2. Taking it a little farther, we're going to distribute it, and we're going to combine like terms at the end, simplify completely. Okay, so for this first one, I've got 2 sets of parentheses. I don't have anything that needs to be distributed. Okay, you don't take this 4u and multiply because there's a plus sign in between. It's 4u plus all of this. So if there was a number in front, like a 3, you would multiply the 3. But we don't have it. It's really a 1. And so when that gets distributed, nothing really changes. If I had a minus out front, that would get distributed as a negative 1, and that does change things. But I have a positive before my parentheses. I have a positive before my parentheses. So really, this all just comes down. You're multiplying by 1 technically. So I'm literally just rewriting this whole thing without parentheses. I've technically distributed a positive 1, but that's going to make it appear like nothing has actually changed. All right, so I have a 4u, I have a 1u, and I have a 5u. That's a 10u all together. And I have a 2t, a 7t, that's 9, and a minus t, so 9 minus 1 is 8. T, I don't have any other terms. Those cannot be combined because they have different variables. That is fully simplified. Okay, now on this one, all of this will end up coming down, but this one I need to distribute. So the first thing you do is distribute. 10 times 12, that's 120f. 10 times negative 2, negative 20, the f squared just comes along. And 10 times negative 3 is negative 30. All of this is going to drop down. And now I'm going to combine like terms. I have 4f squared and negative 20f squared. That's negative 16f squared. I have a 1f and a 120f, so that is 121f. Okay, and then I have a 9 and a negative 30, and that's negative 21, which I'm going to write as a minus 21. If you put plus negative 21, which you'll see on the answer key, that is perfectly fine. That works. You can do plus negative 21 or just minus 21. Okay, 2.3, we looked at number puzzles. All right, we should be able to put any number we want, any variable we want, and no matter what, this last part is going to happen. So for this one, it says your answer should be twice your original number. So whatever number I pick, and then we're going to use 10, it should come out to 20 at the end. Then we also can do this with x. If the answer is twice what we started with, if we started with x, it should end as 2x. So let's see what happens here. So we're going to start by using 10 because that was the directions. Subtract 11. That's negative 1. Multiply by 3. That's negative 3. Add 5 times your original number. So my original number was 10. Okay, so I'm adding 5 times the original. So I'm adding 50. Okay, so that is going to come out to 47. Negative 3 plus 50 is 47. Add 1, 48. Divide by 4, and that's 12. Add 8, and that's 20. Your answer should be twice your original number. 10 became 20, and we're good. Now, where some of you may have struggled here with the first time we went through it is when we tried to do this with x. If we start with x and we need twice the original number, this needs to end up being 2x. So I have to get from x to 2x. So I'm going to subtract 11. How do I subtract 11 from x? I just write x minus 11. You can't combine them. They're not like terms. Multiply by 3. That's like saying 3 times x minus 11. This whole thing gets multiplied by 3. We just talked about distributing. So this 3 times x is 3x. 3 times negative 11 is negative 33. So we have 3x minus 33. Add 5 times your original number. Well, my original number was x. 5 times my original number is plus 5x. 5 times my original number. 5x is 5 times the original. And so I'm going to take this 5x and I'm going to add it to what I had here. And I just combine like terms. The 5x can go with the 3x. That's going to give me 8x. And the minus 33 doesn't interact at all because it's not a like term. Now I'm going to add 1. Well, the 1 can't go with the 8x. That's where a lot of people make mistakes, especially when they're first starting algebra here. All right, that is not a like term. It can only go with the minus 33. Okay, so the plus 1 goes to the minus 33, which would be negative 32. and the 8x stays the same, so it becomes 8x minus 32. I've added 1 to the negative 33. Divide by 4. Everything gets divided by 4. 8 divided by 4 is 2x. Negative 32, it's going to be negative, divided by 2, or I mean by 4, excuse me. 32 divided by 4 is 8. And then they want me to add 8, which only gets applied to the regular number, not the x. Plus 8 added to a negative 8 cancels it, becomes 0. And all you're left with is 2x, which is twice my original number. Okay, so we can show this using algebra. This proves why it works. I can plug any number I want in for x, and I'm going to get twice the original. And we can actually try regular numbers as well. Okay, 2.4. So we talked about opposites. Opposites are like 6 and negative 6, 10 and negative 10. They are the same distance from 0. So which of the following is equal to this? So now we started distributing those negative numbers. So this is like multiplying by negative 1. I'm going to get negative p, and I'm going to get negative 7. So which of these is equal to that? So if we look carefully, this one has a positive p. That's no good. This one we'll come back to. This one has a positive p. That's no good. This one has a negative p, but a positive 7. That 7 has to get multiplied by the negative 1. It would not be positive. So clearly this is the right answer. And remember we said writing as a minus 7 is the same as adding negative 7. So that's why this one works. Okay, for the next one, which one's not equal? So when I distribute this, it's like a negative 1. So I'm going to get negative x. A negative times a negative is a positive y. But another way to show this, adding y here, negative x, we could express this as subtraction of a negative. Okay, so we would have left this subtraction sign alone, and then negative 1 times y is negative y. Now we know minus a negative goes plus plus, and it ends up looking like this, but as we're looking at these choices, we need to consider this as an option. But x is negative, y is positive, unless you see a double negative. All right, so letter A, when I look at that, x is negative, y is positive. That's good. But they're asking which one does not equal it. So this one's good. We're going to leave that alone. This is a negative x and a negative y. So that appears to be the answer to me because we don't want a negative y. If we have a negative y, it has to say minus negative y, not plus negative y. Here we've got this, negative x minus negative y. That's what we just talked about. So this one's actually good. And now here they've reversed the order, but y is positive plus, x is minus, that's negative. So that one is good as well. Okay, explain how you could prove to someone that two numbers are opposites. So the definition says two numbers are opposites. Now, technically they're the same distance from 0, but the way we prove it is we add them together and get 0. So two numbers are opposites if they add to 0. So opposites are like 10 and negative 10. So 10 and negative 10 are opposites. And I'm going to prove it because 10 plus negative 10 equals 0. So opposites are like the positive and negative version of each other. They're the same distance from 0. And the way we prove something is opposite is by adding them together. Opposites will always add up to 0. Okay, explain how you could prove to someone that two numbers are reciprocals. So reciprocals are like the flipped fraction. So let's see, 3/7 and 7/3 are reciprocals. You might not remember that from chapter 2. Okay, the way you prove it is they multiply to 1. So they don't multiply to 0, they multiply to 1. Let's take these two right here, 3/7 times 7/3. It's the flipped version. The fraction, notice I didn't change the sign from positive to negative or anything like that. But when you multiply straight across after you have flipped, you're going to get the same number on the top as the bottom, and that is 1. Okay, so reciprocals are the flipped version of the fractions. The way you prove their reciprocals is you show that they multiply to 1. All right, 2.5, we tested equivalence, which we did in chapter 1 by making a chart and plugging in a bunch of numbers for both and then seeing if the inputs match the outputs, right? So now here in chapter 2, you could still do it that way by making a table. And if you look on the answer key, you'll see it both ways. But we can also now just simplify, and that will show us if they're equivalent or not. So this one, 4n minus 15, is simplified. I can't do anything with that. Don't try and put a 4n together with a 15. They're not like terms. We're going to simplify this one and see if we end up with 4n minus 15, and then that's another way to tell if they're equivalent. So we multiply here, it's 4n minus 16, and then this minus 1 just comes down. That's going to combine here. Be careful, at first glance you might think, oh look, they are equivalent, right? 16 and 1 is 15. Be careful. It's a negative 16 and a negative 1. That's negative 17. And so these are not equivalent. We did not get the same fully simplified version of each. On the answer key, they show the work here by simplifying like we just did, but you can also show it with a table, plugging numbers in for both of them, and you'll see no matter what numbers you plug in, you're not getting the same thing. Similar inputs do not produce similar outputs. So 2 different ways to prove they're not equivalent. Simplifying obviously much faster. Okay, the next one. We're going to distribute here and we're going to distribute here. We're going to simplify. Then we'll do the same thing on the other side. So 2 times 4x is 8x. Here, that's negative 14. A lot of mistakes are made when we distribute a negative, so be careful. This is like a negative 1 times 5 is negative 5x. A negative times a negative is a positive, which I write as plus 7. Okay, now I'm going to combine like terms. 8x and negative 5x gives me 3. It's like 8 minus 5. Negative 14 plus 7 is negative 7. Run that through your calculator if you need to. So I need to see, do I get that on the other side? If I do, then they're equivalent, and if I don't, then they're not. Distribute 3x plus 6 minus 13. Do the math. Just like over here, it might look like it's going to work for a second, but you got to double check. Plug it in your calculator if you struggle with mental math. 6 minus 13, that is negative 7. So I get 3x minus 7. So yes, these are equivalent. And again, you could have done it with a table. It's shown on the answer key. Same 2 original algebraic expressions. We plug in all these different numbers. We're getting the same thing on both sides. We've proved that it's equivalent. Similar inputs produce similar outputs, but it is much faster to prove it using simplifying. All right, and then last but not least, we looked at these number puzzles. And each one of these had 4 ways to read it. You can read it across and then up, and then we're using this sign right here. So x plus negative 8 equals this one, or this way, negative 8 plus x equals. Or you read it down, starting with negative 30, and then you're going to use this one, negative 30 minus x equals negative 8, negative 30 minus negative 8 equals x. So we're going to write the 4 facts that I basically just spelled out for you, and then we're going to use the best one to help us solve for x. Okay, so let's go across this way. That says x plus negative 8 equals negative 30. Go the other way. Negative 8 plus x equals negative 30. Now we know how to solve those, but neither one of those is really set up nicely for us. Going down, negative 30. Now we're minusing x equals negative 8. And these are all equivalent. Okay, these will all produce the same answer if you ran them through. But then the last one here, this is the special one that we're going to use. Negative 30 minus negative 8 equals x. It says use one of the facts to solve for x. So you could use all of them. We have enough algebra skills at this point to work through these and get the correct answer. The reason this is the best one is because x is already by itself. X equals whatever you get on this side. You don't have to do any fancy algebra and elimination on both sides. You just run this. So negative 30, this goes plus plus. So it's negative 30 plus 8. X equals, just plug it in your calculator. You get negative 22, and you have solved for x. Again, we know how to do this. We would add 8 to both sides here and get x equals, and then we'd still get negative 22. So now that our algebra skills are a little stronger, we're not afraid of any of these, but this is the one that we were looking for when we made these fact triangles. We're looking for the numbers on both sides. The variable is isolated, so we just get the answer in one shot. Okay, so 28, same exact idea. Working across, it's now just multiplication and division. Since there's extra room down here, that's where I'm going to work. So going across, 16 times x, which we write as 16x. That's how we show multiplication between a number and a variable, equals 192. We all know how to solve that, right? We divide. Going this way, x times 16, which we could also write as 16x, equals 192. And now division, you could show it as a fraction like we're used to, or you can use the division sign. I'm going to use the fraction because that's kind of what we do. So 192 divided by 16 equals x. We like that. All we got to do is divide and we've got our answer. But think about, that's actually what we would do here, right? We would divide both sides. We would do 192 divided by 16. Again, these are all equivalent. They all will produce the same answer. And the other way to read this is down this side and over. That's 192 divided by x equals 16. So we're going to use one of the facts to solve. This is the easiest one. You just do 192 divided by 16, and you end up with x equals 12.